In this video, we're going to look at calculating the limit as x goes to infinity of square root of x squared minus x minus x. Now, as x goes to infinity, this piece goes to infinity and this piece goes to infinity. So this is an infinity minus infinity case, which means it does qualify for L'Hopital's rule. So we're going to apply L'Hopital's rule. There's other ways of solving this, but I specifically want to look at L'Hopital's rule. And what that means is we can't use L'Hopital's rule right now, but that means we can put it in either a 0 over 0 or an infinity over infinity case, which will allow us to use L'Hopital's rule. So what I'm going to do is I'm going to need to rewrite this. And there might be some trial and error on these as you're getting familiar with L'Hopital's rule. What I'm going to do in this one is I'm going to factor an x out of each of these. And let me show you what that's going to look like. I'm going to do it in 2 steps. So in here it's going to be an x squared, and then I'm going to get left with 1 plus 1 over x under the radical. Now that may look a little weird at first, but imagine multiplying the x squared back through. We'd have x squared and x squared over x, so that would get us back to where we started. Minus x. And what that will allow me to do is I can pull the x out of the radical. So limit as x goes to infinity, x times the square root of 1 plus 1 over x minus x. And now I'm going to factor out the x. So limit as x goes to infinity, I'm going to factor out the x out of both of these terms. X times square root of 1 plus 1 over x minus 1. Okay, that x doesn't disappear. Don't forget, we need a space holder for it, that 1. Alright, we're not quite ready to use L'Hopital's rule yet, but if we check it what form we have, as x goes to infinity, this goes to infinity. And here, this piece is going to go to 0. So we'd have square root of 1, which is 1, minus 1, which is 0. So now we're into an infinity times 0 case. Again, not quite where we can apply L'Hopital's rule, but it's one of the indeterminate forms that tells us L'Hopital's rule is definitely going to be applicable if we rewrite it. Now, a lot of times when we're multiplying by x, not every time, but a lot of times when we're multiplying by x and we need to turn it into L'Hopital's rule, one of the things we can do is we leave this whole part alone. So we leave square root of 1 plus 1 over x minus 1 alone. And we rewrite the x as 1 over x in the denominator. This is very common with L'Hopital's rule. Remember, dividing by 1 over x is the same thing as multiplying by x, which would get us back to this line. Now, we already knew this went to 0. This also goes to 0 as x goes to infinity. We now have a 0 over 0 case, allowing us to apply L'Hopital's rule. Before we do, to make this a little easier to look at, let's rewrite our radical. That's typically the first thing we do as we're getting used to taking derivatives. You might get to the point where you don't need to do that, but I'm going to go ahead and do it because I think it makes it a little bit easier to see our power rule. So I still have not taken L'Hopital's rule yet. Now we're going to take L'Hopital's rule, and I like to put an h just to tell myself and the reader that's what I did to get from this line to the next, is I took the derivative of the numerator and denominator separately. So limit as x goes to infinity. Numerator is going to be a chain rule here. So we're going to have 1/2 times, leave the inside alone, plus 1 over x to the negative 1/2 times the derivative of the inside. Derivative of 1 is 0. Derivative of 1 over x squared, 1 over x is negative 1 over x squared. So that's just the derivative of 1 over x there. The derivative of 1 is 0, so I can leave that off. The derivative of 1 over x, as we just said, is negative 1 over x squared. All right. If you need to review that, remember we rewrite it as x to the negative 1 and apply the power rule. Well, look at what's going to happen now. First thing you should do before you try to reapply L'Hopital's rule is any simplifying. These are going to cancel, and what I have now is the limit as x goes to infinity of, and I'm going to rewrite this back as a radical, 1 over 2 times the square root of 1 plus 1 over x. It's in the denominator because of the negative exponent, and there's already a 2 in the denominator, so you can see where everything came from. Now, as x goes to infinity, this is the only piece that depends on x. This goes to 0. So we have 1 over 2 times the square root of 1 plus 0. That's going to be 1 times 2, and that leaves us with a limit of 1/2.